Hey, so today we're going to look at the problem set from lesson 2 in module 2 of Engage New York Eureka Math 7th grade curriculum. And this lesson is called Using the Number Line to Model the Addition of Integers. So it's all about using these vectors on the number line. Vectors are just arrows, but they have specific length and specific direction. And if we use them over a number line, they can help us sort of keep track of addition. So let's look at number 1. It says David and Victoria are playing the integer card game. David drew 3 cards, -6, 12, and -4. What is the sum of the cards in his hands? So you model your answer on the number line below. So I always start at 0, and then since the first number is -6, I'm going to go back 6 spaces on the number line. And so that's my first vector. It starts at 0, it has length 6, but it's pointing to the left. And then from there, I want to add +12. So I start my next vector just above the previous vector, and its starting point is the last vector's endpoint. So I'm starting at -6, and I'm going to move 12 spaces to the right for this +12. And so I know that 6 would get me to 0. I need 6 more, and now I'm at +6. And then I have one more integer to add. It's -4. So I'll start just above the previous vector, and this time I'm going to go to the left 4 spaces. 1, 2, 3, 4. And I see that my final vector ends at +2, and so that's a way for me to figure out that -2 plus 12 plus -4 equals 2. All right, number 2. In the integer card game, you drew the cards 2, 8, and -11. Your partner gave you a 7 from his hand. What is your total? So we have 4 integers to do on this number line, and there's not a whole lot of space, so I'm going to kind of have to make these really small and close together. So the first one is 2, and so I start at 0 always with my first vector, and I'm going to go 2 spaces to the right. And then the next one is +8, so I'm going to start at the endpoint of my last vector, and I'm going to go 8 spaces to the right for +8, and I'm at +10. Then I need to go -11, so I start at the endpoint of my previous vector, and I'm going to go 11 spaces to the left, and so I know that 10 would get me back to 0, so I just go 1 more from there, and I'm at -1. And then it says my partner gave me a 7, so I guess I'm going to have to cover up the words a little bit. I'll go between the words right here. I'm going to start at my previous, the starting point of this vector will be the same as the endpoint of the previous vector, and I'm going to go 7 to the right. So 1 gets me back to 0. I have to go 6 more. There's 1, 2, 3, 4, 5, 6. And so I end at +6, and so that's a way for me to see that 2 plus 8 plus -11 plus 7 equals 6. It says B, what cards would you need to get your score back to 0? Explain. Use and explain the term additive inverse in your answer. Well, I would need the additive inverse of 6. Right? I want the card that adds this 6 and makes 0, and that's what additive inverses are. They're numbers that add up to 0. I'll put a comma there, comma, which is -6 because 6 plus -6 equals 0. All right, number 3. If a football player gains 40 yards on a play, but on the next play he loses 10 yards, what would his total yards be for the game if he ran for another 60 yards? What did you count by to label the units on your number line? So yeah, I don't think it makes any sense for us to try to think of this as 1, 2, 3, 4, because that would be a lot of work to go 40 and 60. So I think I'm going to mark these as tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Let's see, he goes 40 yards, and then he loses 10, and then he gains another 60. So it doesn't sound like he's ever going to go into the negative part of the number line. So I'm going to save myself the trouble and not number over there. I'm going to start my first vector at 0. And he gains 40 yards. So gain is positive. That's a vector to the right with length 40. And then he loses 10 yards. So losing, that's negative. That's to the left. And so I'll go to the left with another vector, 10 spaces. 10 units, I guess is a better word to say. And then from here, I'll start my final vector at 30, where the previous one ended. And he gains another 60 yards, so that's 60 units to the right.
Mr. Thomas, is he in here?
That should end at 90.
Did he come today? No, he didn't.
Okay, so moving on to the next page. Number 4 says find the sums. You know what? I'm going to let you do that without my help. I think you can do that. Number 5. Mark an integer between 1 and 5 on the number line and label it point z. Okay, so between 1 and 5, how about 2? 2 will be my z. You don't have to pick 2. You can pick a different one. Then locate and label each of the following points by finding the sum. So point A will be z plus 5. So my z is 2. So 2 plus 5 is 7. That's point A. So I label 7 with an A. B, it says z plus negative 3. So if I were at my z, which is 2, and then I added negative 3, that'd be to the left 3 spaces, 1, 2, 3. So negative 1 would be my point B. Point C says negative 4 plus negative 2. So let me go to negative 4 first. Negative 4 is here. And then I add negative 2. So that puts me down to negative 6. And then I'm going to add my z, which is positive 2. So I move to the right 2 more spaces, and I get to negative 4. So there's my c. You might have a different b, a different c, a different a, a different c, all depending on which z you chose at the start. Okay, I'm going to go ahead and leave D. I think you guys get the idea on that one. Number 6, write a story problem that would model the sum of the arrows in the number diagram below. So there's 3 vectors here. It's a positive 9, then a negative 9, then a positive 5, with the final sum being positive 5. So you just write a story problem in which somebody gains something by 9 or loses something by 9 and then gains 5 at the end, or is moving up 9, down 9, up 5, something like that. I'm going to let you do that. So I'll look at number 7 though. It says, do the arrows, I like the word vector better. I'm going to cross that out and say vector. Vectors. Do the vectors correctly represent the equation 4 plus negative 7 plus 5 equals 2? If not, draw the correct model below. So it starts at 0 with the first vector and goes to positive 4. So that's good so far. But then I see this mistake that they've made where they didn't start their second vector at the endpoint of the previous vector. They started it at 7, maybe because they thought that negative 7 should start at 7. But that's not the way it works. So this is not a correct model. So I'm going to draw my correct one underneath the number line. So my first vector will do the same thing their first vector did. That part was good. It'll go to the right 4 spaces from 0. But then my second one, instead of being shifted over like theirs, I'm going to start at 4, and I'm going to go 7 spaces to the left. So there's 4, 5, 6, 7. So now I'm at negative 3. Now I need to add 5. And so I'm going to start my vector at the endpoint of the previous one, and I'm going to go 5 spaces to the right. 1, 2, 3, 4, and 5. So my last vector ends at positive 2, which is the right side of the equation there. So there's my model. And I think that's all I got to do. So, all right, that's it.